So in this episode, we're gonna talk about array and the application of static array in C or C++. Static array is an array in C or C++ which has a fixed size. On your screen, you are seeing an array of 10 integers. So each of these integers takes up 4 bytes of memory. So therefore, the whole array of 10 integers gonna take 4 times 10, which is 40 bytes of memory. So you can see from the memory address here that uh, the array of 10 integers is gonna take up 40 bytes of memories, addressing from 200 to 239, including 200 and 239 themselves. So there are a total of 40 bytes being occupied by an array of 10 integers. This is fitting the fact that each integer takes up 4 bytes of memories, and 10 of those integers gonna take up 40 bytes of memory. So static array have the size or length determined when the array is created and or allocated. In this case, when you declare the array, you have to specify how many elements are there in the array uh, before you assigning the elements to the array itself. In this case, we have to predetermine that the array gonna have the size of 10 integers. So for this reason, they are called fixed size array or fixed length array as a consequence. So there's a structural difference between the static array and the dynamic arrays, because we have already declared or defined that the static array is defined or limited in the uh, memory capacities. So when the static array is being full and you want to add a new element into the array, the element will not be added into the array and gonna lie outside of the arrays. Whereas for the dynamic array, it can grow or resize itself to double its current capacities, and the new element can be inserted to the first 3 blocks of memory. So in our scenario we are talking about, which is the static array, if the memory limit is being reached, you cannot insert a new element into the array. So here's an example code of the static array in C++. So to execute a static array, first of all you have to define the data type of the array. So in this case, it's the integer data type. Then you have to declare the name of the array, which is A in this case, and you have to declare the capacity of the array. So in this case, I want it to store 5 elements, and then you can assign the elements as you wish, as long as their data type satisfy the predetermined data type that we give to the array. After that, you can access the element by traversing the index of the array. The index of an array gonna be starting from 0 to n minus 1. In this case, I run from 0 to 4, 0, 1, 2, 3, 4, which is enough for 5 elements of the array. So in this episode, we're gonna examine the behavior of a static array in the case of the overrange query or out index query. So for example, for an array of 5 elements in the screen, the elements are 1, 8, 7, 4, and 2, respectively, with the indexing is 0, 1, 2, 3, 4. However, in our query, we want to access the memory blocks from 0 to 7, which is I from 0 until I less than 8. So you can see, even though we only have 5 element, we are asking the program to querying 8 elements. So because 5 is less than 8, so this gonna cause the overrange query that we are talking about. So when the overrange query happens, the memory blocks that is not initialized by the array gonna return garbage value. As you can see here, after number 2 on the screen, the next 3 numbers are just garbage value randomly generated by the computer uh, rather than the value generated by the user. So we can see that whenever we try to query an unassigned memory block, garbage value gonna be returned, because those are the numbers that is randomly generated by the system. So the static array is used in the case the size of the array or the maximum size required for the array is specified. Also, the data type of the elements in the arrays must be similar, aka homogeneous. So we can recap about the requirements for static arrays. There are 2 requirements. First of all, the size of the array has to be specified, and also the data type of the array has to be homogeneous. So for example, you can see on the screen, there are a static array of 5 integers. So all the elements inside the array are integers, so the array is homogeneous, and the size of the array is specified, which is 5. So for each integer, it's gonna take 4 bytes of memory. So for these 5 integer arrays, it's gonna take a total of 5 times 4, which is 20 bytes of memory. So here is the C++ code to execute the static array that we have discussed previously. So for this array of 5 elements, the index gonna be starting from 0 to 4, 0, 1, 2, 3, 4, which is 5 elements. So we're gonna talk about the pointers, which are the address array variables inside the memory regions. So the address of the entire array is actually the address of the first element of the array in the memory. So to recap, the address of the entire array is actually the address of arrays number 0, which is the first element of the array. So we're gonna do an experiment to see that the address of the entire array in the memory is actually the address of the first element of the array. So you can see when we initialize the arrays and we check for the address of the array, and we accessing the address of the first element of the array, they actually generate the same number, which is the same address. So this means that the address of the entire array object is the address of the first element of the array. So here's another way to run the program. So now we're going to talk about the memory architecture of a static array. So for a static array, the entire array gonna stays on the stack section of memory, which is the higher address memory region. So both the data and the object of the static array lies on the stack section of memory. So let's run an experiment to determine this. So the signal for the fact that an object lying on the stack section of memory is that the address when we dereference has the value of 0x7ffcs, whereas the address associated with the heap section of memory is gonna be lower, which is 055f or 0x6f. So in our case of static arrays, we should see an address of 0x7ffc or something like that, which signifies a location on the stack section of memory. So to recap, the address of 0x7ffc gonna be associated with the stack section of memory, whereas the address of 0x55f0 or 0x56 or 0x6f gonna be associated with heap section of memory. So you can see that the address of stack section of memory is higher than the address for heap section of memory. So as you can see on the screen here, when we reference both array 0 and array 8, we all get an address of 0x7ff something, which signifies that these elements are lying in the stack section of memory. So when you dereference array 0, that gives you the address of the element inside the array, which lies on the stack section of memory. And when you dereference the array itself, it gives you the address of the entire array, which is also lying in the stack section of memory. This is congruent to the fact that we have discussed earlier that both the object and the data of a static array all lies in the stack section of memory. So that is enough for today's lesson about static array. You can reference this video on YouTube or the memory layout of a C program to understand deeper about this memory address I'm talking about. On the next time, we're gonna discuss some application of static arrays, which are the famous prefix sums. Thank you very much for joining in. See you in the next video.